nuestro seminario y especialmente a nuestra invitada de hoy, Cecilia Aragón. Ella es de la Universidad de Washington, dirige el Humancentered Data Science Lab de la Universidad de Washington y es realmente un agrado que ella nos pueda acompañar. Antes de partir, quisiera recordar que ¿cuándo tienen que mandar la primera versión nuestros alumnos de seminario posgrado el abstract? Estás muteado tú ahora. Enrique, estás muteado.
Sí, perdón, reviso y le digo al tiro, permítame.
Quiero dar ese dato para que no se descuiden ellos. 18 de mayo, dice Luciano Hidalgo.
Sí, 18 de mayo.
18 de mayo, o sea, tienen, ¿cuántas semanas? Tienen
3 semanas.
3 semanas. Así que no se descuiden en mandar la primera versión del abstract. Eso, no perdamos más tiempo. Agradezco mucho a Cecilia realmente que se haya tomado el tiempo de estar con nosotros hoy día y de darnos esta charla. Cecilia, todos nosotros acá para escucharte. Puedes hablar todo el tiempo que quieras, esto termina 10 para la 1, ojalá pudieras dejar 10 minutos para preguntas, si quieres un poco más, como tú desees, y después, ¿cómo se llama? O si quieres en entre medio, tienes alguna consulta, nosotros estamos acá por cualquier cosa. Muchas gracias, Cecilia.
Muchas gracias, Miguel, y bienvenidos a todos. Y lo siento que necesito dar la charla en inglés. So I will begin in English, and if anyone has any questions, please feel free to interrupt, and you can ask questions in Spanish and ask me to clarify. So I'm delighted to be here. I'm going to share my screen now. Right, so can everyone see the
Yes,
screen?
we see the screen.
See it, great. Okay, why does it say it's paused? Right,
But we don't see it in the presentation mode. We see it just in the
okay, you
mode.
don't see it in, that's interesting because I
Maybe
I see it.
Other screen?
Yeah, let's try this.
Share the other screen.
Yeah, I'm going to share the other screen and let's see what happens.
Yes, there it is.
That's better? All right.
Much
great.
better.
Excellent. All right. Let's see. All right. All right, so now I can begin. My talk is called The Rigorous and Human Life of Data. And I want to start out by asking the question, are rigorous and human-centered opposites? If something is focused on the human? Does that make it soft, weak, or less technical? And I admit I used to believe this because I had a very traditional computer science and statistics education. I started out working in industry using machine learning and statistics to analyze what were considered very large data sets at the time. As a matter of fact, we even had to write our own protocols to transfer large volumes of data efficiently because TCP packets had too high of an overhead. I remember crawling through the ceiling to help pull cables. And then I moved to government labs and NASA, analyzing scientific data such as airflow across aircraft and spacecraft, computational fluid dynamics, astrophysics, and supernova data. And I admit, perhaps because I didn't like being stereotyped, that I tried to present myself as a hardcore engineer. If the software was hard to write, it should be hard to use. But the more I worked in data science, the more I became convinced that it was the human-centered piece that was the most important and the most difficult. So I transitioned to academia because I felt I could have a greater impact on the field. And in the past decade, I've accomplished a number of items in human-centered data science, and I'd like to give you some examples and highlights from my career. So here is the 30-second view of my career. I particularly want you to notice that there was a bit of a gap in the 80s and 90s where I stopped off from computer science and became a pilot. And not an airline pilot, but someone who flew airplanes upside down. So why? Why did I do this? It turned out that I had terrible imposter syndrome. And the way I grew up, I did not believe in myself. I was afraid that I wasn't smart enough to get a PhD and be a computer scientist. And so I felt, not consciously, but unconsciously, that succeeding in school and a career was scarier than facing death in an airplane. So I want you to think about that for a moment. So if any of you have ever felt an emotional block against doing data science or computer science or artificial intelligence, if you have tried to talk yourself out of a career in this really exciting field, consider that it may not be your lack of interest or your inability to do the work. It may be that societal expectations or your upbringing may have led to beliefs that you're not aware of. I actually had to face my deepest fears in order to finish my PhD in computer science. And I like to talk about this because I want people to see that it wasn't a smooth road to where I am today. I almost gave up. I remember telling myself that maybe I'm not cut out to be in math and computer science. Certainly when I was a PhD student, I had a professor who said, oh, women aren't capable of doing the intellectual work of computer science. So I almost changed my career. And I don't want anyone to ever think that you might not be good enough or interested enough to do this important work, because there's a lot of work that needs to be done and we need everybody to participate. So, for now, I just want to let you know that it's possible to succeed in your career, raise a family, and have hobbies you love. So don't let anyone tell you you can't. All right. So now let's talk about the important stuff, about human-centered data science. So I hope to convince you of 3 points. Why it's necessary, why human-centered approaches to data science will make your technical work stronger, and why data science of any kind is human-centered, whether we believe it or not. So we'll start with the first point. Talking about human issues in data science is necessary. So I think anyone who has dealt with automated systems has an intuitive grasp that machine learning and artificial intelligence have significant flaws and gaps. So we studied this in a paper we wrote on folk labeling. We noted how many times automated systems didn't work the way their designers intended them to work. And humans had to fill in the gaps by posting these little labels. So we collected all these hand-drawn signs. And I'm sure you've seen them too in airport bathrooms or in rooms with, you know, highly technical lighting systems. So that is kind of a minor, it's kind of a minor issue, but I think it's very illustrative of, you know, why we can't just say, oh, artificial intelligence will take care of everything for us. Because sometimes the consequences of improperly designed automation are far greater. So in her book, Automating Inequality, Virginia Eubanks described an attempt to privatize and automate Indiana's welfare eligibility program in 2006. So it was a disaster. Thousands of people lost benefits. People just received these automated cancellations that they couldn't appeal. You know, and some even died. There was a 6-year-old girl with cerebral palsy who was denied Medicaid benefits for failure to cooperate because she didn't respond to an automated notice. And there was no way for her parents to contact a human to explain what was going on. So this was billed as an attempt to save taxpayer dollars and prevent fraud. But not only did it cause a huge amount of human suffering, it ended up costing the state of Indiana far more than it saved. There were so many lawsuits. And Eubanks says, automated decision-making can change government for the better. And tracking program data may, in fact, help identify patterns of biased decision-making. But justice sometimes requires an ability to bend the rules. By removing human discretion from frontline civil servants and moving it instead to private contractors, this Indiana experiment supercharged discrimination. And I think this is very, very important to realize. If you are ever building an artificial intelligence or data science system, think about ways to enable humans to jump in and bend the rules. That is going to be critically important. Do not remove the humans completely from the system, or you will also end up with these unintended costs later on. All right, so that's one piece, why it's necessary to think about human-centered approaches. But in addition, what I have found in my own experience, in my decades of working in pure data science and artificial intelligence, is that even beyond the ethical imperative, guess what? Human-centeredness in data science makes the technical work stronger. So I'm going to give you one example from my own work, just one of many. So I was hired to solve a big data problem on an astrophysics project back in 2005. And this is just an example of many of these projects that I worked on. So I was supposed to build software tools to facilitate supernova detection and analysis. And when I was hired, 2 other software groups had tried and failed to solve the problem. And then they brought me in, you know, no pressure, Cecilia. However, I was able to make 4 major contributions to the software. The first two are purely technical, involving statistical machine learning support vector machines, boosted decision trees, and Fourier contour analysis, algorithms that I implemented into their pipeline. And the second two are social, having to do with successful collaboration building and solving some issues building cross-cultural scientific teams. It turned out that some of the problems they were having with collecting data were social and cross-cultural issues. But it's important to note that even though some of these were, the first two were purely technical, all four of them were discovered through a human-centered ethnographic approach. And all four contributed to the ultimate success of the science. So I love to talk about all of these items, but due to time constraints in this talk, I'm just going to talk about example 2, a novel image processing technique that I developed that led to substantial improvements in supernova image classification. So just to give you some background here, we had to process 600,000 images per night that looked like these 6 images on the screen. And in 2005, that was considered a lot. And it actually took 12 hours to do all the processing that we had to do. And we had to see which of these white blobs were potential supernova, which are exploding stars. They're incredibly bright, and they only last for a few weeks. So you have to find them rapidly. So the top row of these 3 images shows left to right multiple co-added images of a galaxy on the left, and then in the middle, a single image of the same galaxy from the previous night. So that's just one image, so you can see the resolution is lower. And then on the right side, a subtraction of the 2, which shows you this nice round supernova. So that is what you want to get. But on the bottom row, this is what they call a bad subtraction. On the left-hand side, you see a star, and next to it in the middle is a picture of the same star, but notice that it's right near the edge of the image. So this leads to a registration error, with the result that the final image on the right, the subtraction, is this C-shaped thing, which is not a star. It's just an error, a bad subtraction. Now, it turns out that of these 600 images, the vast majority that came out to be positive, by our machine learning software, were bad subtractions which needed to be discarded. They were false positives. But by observing the scientific team as they went through their daily work, I realized that an existing image processing technique, which they weren't aware of, known as Fourier contour descriptor analysis, could be modified to automatically detect the shape of the supernova candidate. Since supernova are round, we could add additional shape features to the set used by the machine learning algorithms. All right, so I implemented 2 new features in the data pipeline to measure the object contour eccentricity. So we called them roundness and irregularity. So why, though, was this a human-centered approach? Well, the scientists didn't ask for it in their requirements document. They had no idea that this is something that could be automated. And as a matter of fact, when I first mentioned the idea of using Fourier contour descriptors, the scientists' reaction was, oh no, Fourier transforms are too slow. We're already at max in terms of our processing speed overnight. But I said, I think I can develop a constant time algorithm to solve the problem, right? Because of the nature of this issue, I go through all the math here. If you're interested, there's a link to the paper underneath, and you're welcome to read up on how we modified a standard Fourier contour descriptor to actually make it constant time. So in the end, this particular feature produced a 41% reduction in false positives with no measurable increase in running time. So this was a technical improvement that was arrived at via a human-centered approach. The previous teams had been, they hadn't even thought about using Fourier contour descriptors. So they did not take a human-centered approach. They used a traditional, requirements document approach, and that's why they didn't succeed at this very difficult technical problem. So in short, there were this and the other improvements to transient search and astronomical transient search and data analysis were measurable and significant and led to better science. So overall, with all these approaches, all the 4 approaches I talked about, we ended up with significant reductions in false positives that actually led to a 90% labor savings. When I joined the project, there were approximately 6 to 8 people working 4 hours per day each, postdocs and grad students. And after my improvements, it was 1 person working 1 hour per day. So once when I gave this talk, someone asked me, well, are you putting postdocs out of work with your algorithms? And so at that time, I showed them a graph that demonstrated that before I joined the project, there were very few publications being authored. And afterwards, all these postdocs were now doing science and writing papers instead of doing grunt work. So the idea was not to completely automate the system, but to build a human-centered data science system that included algorithms, but that had the final decisions being made by humans, but just removed the grunt work from the humans. So this all came from a human-centered approach that involved a data scientist, me, with a background in computational techniques and a background in ethnography, social science, and human-centered design. So this was a very powerful combination. And okay, this is one of my favorite slides. Our principal investigator, Saul Perlmutter, shared in the 2011 Nobel Prize in Physics for this work. Now, I'm certainly not going to say it was because of anything I did. It was all his idea. But he did say in his acceptance speech that the work was the result of a team. And he named me as one of the key team members. So that's the closest I will ever get to a Nobel Prize. So I will take it. All right, and my third point that I want to close with is that data science is actually human-centered, whether we believe it or not. So data science is often presented as this very clean and impersonal sequence of computational operations. People assume that the human element has been scrubbed from the data. These data are unbiased. However, people touch the data in nearly every step. And as they do that, they introduce their own biases and opinions, and that gets wrapped up into the data and inextricably added into it. So I'm going to highlight 5 key locations, places of human intervention in data. So first of all, there's discovery. We talk about these five steps in our new book called Human-Centered Data Science and Introduction that just came out last month. So discovery is when someone encounters a data set and decides to use it. Well, that's a human decision. So which data set do you decide to use? Are you using a data set that incorporates biases? You might not know, or you might not care. And that decision, you are touching the data. Number 2 is capture. This is the process of actually acquiring a data set, scraping or collecting it into a data set. Well, a person will write the code to do this. And that person needs to understand the data and its origins, or unintended biases could creep in. We give a number of examples in the book. Number 3 is curation. And data curation is when the person capturing the data, or maybe someone else, alters it to have it make more sense to a human. Then there's design of data. And this is how we categorize data through sets of choices. I'll talk more about this one in the next slide. And finally, step 5 is creation. People create data by adding records to a data set through labeling. And this is always done. And I'll tell you that this even happened to this astronomy data that I was dealing with. Astronomers disagreed on galaxy descriptions and actually told me to make sure that I put in the name of the person who added the new galaxy labels, because some of them had a reputation for having a different view from the mainstream. So I want to emphasize, all right, before I continue, that this intervention, this human intervention, is necessary for high quality data science work. But the goal is to make these interventions while paying attention to where biases might creep in, and to do it in a responsible and accountable and, above all, transparent manner. So if you make a decision to remove some data, or to alter data, or to acquire data in a certain way, make sure that's transparent to whoever uses your data set later on. That is critically important, because data gets used and reused. And there's so many examples like where, a data set that might have originally been used, say, to understand, say maybe they were looking at housing and buildings in a city. It might have originally been an architectural data set, and then later on it's used for census purposes to discover how many people are living there. And whenever you change, the end use of the data, there are unintended consequences that creep in. So please be careful and make sure you make it clear as you're developing these data sets what you did and why. All right. Okay. So let's talk about the design of data. So what does that mean? Some people say, well, data isn't designed, it just exists. Well, it needs to be cleaned, it needs to be wrangled. That's a human activity. And this happens even in scientific data, and much more in human-generated data or data about humans. So for example, in geology, there is the use of established color charts to describe the appearance of Earth samples. A human assigns these colors to the Earth samples. It's not done automatically. Or the classification of species according to previously established taxonomies. So the goal, of course, is to reduce the messy data into seemingly straightforward classes that can be represented by labels and columns in the database. So it has it's a good reason to do this, and it's necessary to have high quality data, but recognize that a human is touching this. And so this design of data takes many forms. And again, I could give you so many examples, but I need to make sure I don't talk to you for 3 hours. All right. So hopefully, having convinced you in this brief talk that all data is human and is touched by humans, why did we ever believe that data science should be separated from humans? And more importantly, what can we do about it? Well, I believe that it's partly due to flawed mental models outdated benchmarks and data sets, and our traditional methods of teaching students of engineering. So mental models, which are our emotional or shorthand opinion of what a system or machine does. I admit I had this as well, because I grew up reading a lot of science fiction as a child, and there was this benevolent AI trope in fiction and nonfiction. So the idea is machines are unbiased. Robots will save us from ourselves. The overriding flaw in our society is human error. How many times have you heard this phrase, human error, and heard it to blame for an aircraft accident? You know, well, humans don't just make errors. They also, machines make errors too. And as a matter of fact, machines will amplify the human errors that are programmed into the software. So the other issue is our society has come to value efficiency at all costs. And I admit I blame the United States for spreading this mantra, that the whole idea is that the lowest cost way to accomplish something is the best. And cost is measured only by dollars. It's not measured by, human benefits, by happiness or by health. It's measured only by dollars. And that really is not necessarily the best way, because there are other factors that can make systems better. And also, as I mentioned before, with that Indiana system, very often being super efficient immediately results in being very inefficient later on. And you need to think not just about what's going to be efficient and cost effective now and in the next 3 months, but also in the next 10 years. And that is vital, really, from an ethical standpoint, but also from a cost standpoint. So what I believe we really need to do is to change our mental models, because machines do reflect the bias in human society. And we must think of machines and algorithms and artificial intelligence as fallible, as somebody who's very good at computation, perhaps, but that may be more like an idiot savant, that because even more than reflect, algorithms can amplify bias. So as Virginia Eubanks pointed out in Automating Inequality. So this means a change in our mental model from assuming that the automation should just take over and we get the biased humans out of the loop. That is a mistake. What we need to do is think about it as a human AI collaboration, where the humans take advice from the AI, but that they override it, and that it is normal and natural to override the automation and the artificial intelligence. And that is something that we have to change in our teaching. And we have to explain that when you develop a system, you need to make sure that you don't say this will solve all your problems. You just need to sit back and push a button. But instead, you need to think more deeply about what the algorithms do. You need to make the algorithms transparent and understandable. This is known as explainable AI. A lot of work is being done in this area, and it's very important. All right. Okay, so another major problem with how data science, machine learning, and artificial intelligence is that they're often measured with outdated or biased benchmarks or data sets. So this is an example, but there are many, many examples of this. excuse me. So I attended a natural language processing dissertation defense where they claimed to detect binary gender in human-generated text with high accuracy. So I was a little surprised about this, and I asked about it in more detail. And it turned out this algorithm was based on a data set from the 1970s from a single geographic area in the United States, where the males were engineers and the females were housewives. And so I asked, well, don't you think there might be confounding variables in this data? And the response was, well, this is the best data set available. And so obviously I selected, well, let's collect a new data set. And all the experts in the room rolled their eyes and said, that's a huge amount of work and would cost a tremendous amount. So what was left unsaid is there is no funding and there are no career benefits from collecting a better unbiased data set. So that needs to change. We obviously need funding from governments and industry to update our data sets and benchmarks. Organizations need to provide funding and career incentives for this work, which may not be as exciting as coming up with a novel algorithm that gives you a few percentage points better than the state of the art in machine learning. But that's what we've traditionally taught students of engineering to value. And I just want to say there are many more examples that can actually have some very negative effects. So there's certainly a great deal of work that's been done on the dangers of facial recognition and how it depending on your the skin tone of your face or your gender, it actually can make some pretty serious errors and misidentification. So we really need to think about very carefully about which data sets are used. Were they used with people's permission? There's so many important questions that need to be asked in human-centered data science and human-centered AI. And all of these questions still need a lot of work to deal with. And we also need to change how we teach. I mean, this is something that I believe very strongly. I don't believe that you can have a single ethics course or a single course on human-centered data science, and then you're done. I think ethics and human-centeredness need to be taught in the most traditional engineering courses. And when I teach machine learning, I bring up these points. Not only do I talk about the algorithms, but I also talk about unintended consequences. And I think that's really important for all of us software developers, data scientists, everybody who implements code, that we need to do this. So in summary, how do we build ethical and human-centered algorithms, data science, and artificial intelligence going forward? This is really my goal at this point in my career. And I want to leave you with 5 more key points of change that I hope that you can think about. So first of all, I think companies and organizations should recruit data scientists who have an interest in ethical design. So, when you're interviewing for a position, a data science position, ask the person you are about to hire, what do you think about unintended consequences? Do you consider, when you build your algorithm, do you say, well, I'm only an engineer, it's for somebody else to think about the results? No, I mean, that is not true. Engineers need to think about the ultimate end of their software. It's not just whether it's efficient, it's what happens when it's actually interacting with people, when the results are actually making a difference in the world. So think about the ethics. And the other thing I wanted to do is empower engineers to think about ethics. It's something that we all have in mind. We all kind of think of ourselves as ethical people. We think we want to do the right thing. And ethics is not some, well, I mean, there is a field of ethics that is quite complex, but the fact is we know you don't need to be an ethicist to write software that is ethical. You just need to think through what the consequences of what you're writing. All right, so that's one step that everybody here in this room hopefully can do in either their teaching or their writing of code. And but then in addition, we should advocate for there to be policy, governmental policy around data science, artificial intelligence, data sets, and benchmarks. And that means we really need to devise and disseminate new mental models, new benchmarks. We need to fund and incentivize creation of data sets and benchmarks. And this needs to be done from a governmental standpoint. So if any of you, go into a funding agency or review funding proposals, bring these issues up, because it's really going to matter, whether we end up with more bad, biased artificial intelligence that impacts people's lives negatively, or whether it can actually help us to really solve a lot of our problems, which it does have the potential to do that. I mean, there's a tremendous amount of good that data science and artificial intelligence can do. We just have to make sure that we don't let it loose without guidance. All right, so that segues into the third point, which is that we need to study how data science and AI impact people and design algorithms that take this into account. That means we need researchers from the social science point of view, sociologists, social psychologists, ethicists, people from a humanistic background that can actually study this and translate their work and their understanding into terms that computer scientists and programmers and data scientists can build the algorithms that take these effects into account. So we should be reading social science, and and if you don't want to read all these elaborate books about data science, these elaborate books about very abstruse social science and sociology. I'm sorry, I don't mean to keep talking about our book, but this book took a lot of work to write, and we wrote it so that we could do this. And so we summarize a lot of the important sociology results that are related to data science in a single chapter. So this book is not very long, and we designed it to be easily readable by anybody with you don't even have to have a background in data science. And it actually summarizes a lot of data science algorithms in a very simple and accessible way. So we hope that it will be helpful to people in general. All right, then we need to develop best practices, because when the rubber meets the road, that's an expression in English that means when you're actually implementing, when you're sitting at your desk writing code, what are the best practices for work in data science? And there are ways that people have already developed, and you can use these. And again, in our book, we talk about it, but certainly you can also think about it as well. And then finally, the last step is to teach the next generation of engineers. So this is why I'm giving this talk to universities around the world and to teachers and professors, and to say, please, if you want your engineers, your students to be truly effective and not just ethical. I mean, that's of course important, but also to be really good and efficient at how they write their data just like I said in my point 1 at the beginning of the talk, they need to consider human-centered work. It's not, human-centered work makes data science and computation more rigorous. It's not the opposite. So finally, how do we actually build this? Well, it's people, all right? So data scientists, students, this is a group from my alma mater at the University of California, Berkeley. It's the students, the data scientists, the people. And so I really challenge all of you who are looking to do artificial intelligence, to have a career, bring your unique ideas and viewpoints into the field of data science. And by doing so, you will change it. And it's not easy to make major changes like this, but it is truly necessary. So thank you very much.
Thanks a lot, Cecilia, for this very interesting talk indeed. Now comes the conversation and questions. And I would like to start with perhaps a philosophical question. The key issue is ethical software, but there's no definition of what ethical means. And we're living in a very biased society. The US is a very biased society.
Definitely.
And if we look in a more macro way, the world is even more biased. Just look what's happening with Russia. So how do you define what's ethical? And yes, go ahead.
No, thank you. This is a wonderful question. And the best way, so first of all, people who go into engineering tend to be intelligent and tend to be imaginative. And the best way that I teach ethics in my classes is I say, imagine what will happen if you write this software. Imagine the consequences. Think about the ethics. Think about what could go wrong. All right, so one of the efforts that's being made in one of my fields is that every paper should also include a small section on what could go wrong with this idea or the tool. And I think that's very important because we're so used to writing papers that talk about all the great things that our idea could accomplish. And we should also think about what are the things that could go wrong. What are the mistakes that could be made? And I think we all have an intuitive understanding of what is ethical. I mean, in our daily lives, you don't have to be an expert in ethics to write software that is more ethical. You might make mistakes, but then take this idea to other people. It actually helps if you get a group of people discussing, I have this really cool tool, you know, but what could go wrong? And you talk to your colleagues and say, is there something I'm missing? And especially if you have a diverse community, if you have people from, you know, all different walks of life, you know, socioeconomic backgrounds, races, genders, people bring different ideas in, and that has been shown to make much more effective and efficient tools in so many environments. So first of all, have confidence in your own ethical thinking and try to imagine what could go wrong. How could this hurt you or the people you care about? So if you have an elderly person, is your software maybe too confusing for them? Don't just write it for, you know, a certain demographic. Imagine how somebody could misuse your software and, you know, unintentionally, and see if you can design in ways to correct that. So thank you for that great question, because I love answering it. I want to say everybody here can think about ethics. You absolutely can. You don't need training in it to think about what's right and what's wrong, you know.
And I leave open the floor for questions. Si quieren hacer preguntas en castellano, Cecilia entiende castellano. El problema es que ella tiene pocas oportunidades de hablar en castellano, por lo cual le cuesta más expresarse, pero ella entiende perfectamente el castellano, así que si hay
Sí,
problema, yo les ayudo.
habla despacito, por favor.
Así que, si, por favor, ¿cómo no van a haber preguntas? Tenemos 16 personas, ojalá que alguien pudiera hacer una pregunta. Mientras ustedes piensan una pregunta, voy a hacer otra. I like very much the Indiana example where you leave the whole responsibility to the system. Yeah. Even so, you don't leave the whole responsibility for the system when you have data mining algorithms that you don't know really what they're doing. You give the responsibility to the algorithms. How can you be accountable of those algorithms?
So this is a growing field now called, interpretable artificial intelligence or explainable data science or explainable machine learning. And this is something that people have been doing for a while. So I know in my own work, I would often choose, if I was choosing boosted decision trees over, say, deep learning, I might do it because the algorithm that I was using would explain what are the top 5 features that, led me to this decision. And more people who are developing algorithms are incorporating this type of transparency and explainability into their system. So I encourage you to go into this field to think about how do you build algorithms that are also understandable by a human? What outputs can you give besides just a single number? It's likely to be, positive. It's likely to be classified in this certain area, 85%. No, say why. Why, if this is a digit that's a 7 versus a 1, it's because of, it has a bar through it. In certain cultures, 7s are crossed with a bar. Okay, I mean, examples like that. This is the sort of, that's a very simple example, but explaining features to the end user is a wonderful way to do this. And a lot of people are working in this field now. It's very important. So.
Dennis, go ahead.
Hola, Denis.
Hola, Cecilia. ¿Cómo estás?
Muy bien.
Gusto verte. Gracias por la presentación. I'm gonna make my questions in English slowly too, so the Spanish speakers can understand. So we are in both ways. You know that we recently were awarded a big grant in Chilean terms for the National Center of Artificial Intelligence. And not one issue, but one aspect that we are addressing, and we don't know very well which is the best way, is the fact that there are no IRB committees for AI or data science. So at the Catholic University, we have a ethical committee in medicine, which is very well known. It has a certification even. So even if they make decisions related to research, not only within the Catholic University, they are valid even for hospitals or other institutions within Chile. There is also for social sciences. They are very careful in all the decisions related to collecting data, for instance, social networks, Twitter, stuff like this.
Yes.
But the idea of we don't want to create a committee for AI because we think that can be too much of an effort, like creating a committee. So I wanted to ask your experience. Have you, at the University of Washington or any other institution, have you created a committee for AI, an ethical committee? Or if not, what do you think should be the characteristics of this committee in order to perform well in dealing with all the aspects that you have been describing in your presentation?
All right, this is a wonderful question. Thank you, Dennis. So yes, you put your finger on a big gap. When a person develops an AI algorithm, and the IRB only deals with human subjects, so if you just write your algorithm and you never test it with people, you don't have to do it. So, but if you do have to bring people in to look at your algorithm, then yes, we do have to submit it through the IRB. But yeah, a lot of people don't. For a computer science dissertation, you do not need to test your work on, on the end users it's intended for. So yeah, it's a gap. And I think that's something, I don't think there's, obviously having a committee to look at algorithms is not something that could be done by our traditional IRB. It just wouldn't work because they don't have the expertise.
Yeah.
So what I would, yeah.
That's what I was thinking, because
right.
Sorry for interrupting you, but
no, go ahead.
To add one more aspect, so we make it like a conversation. Conferences like New Reps or iClear, they are requesting the author of the papers, even in the cases that you described. You write an algorithm and there is no user involved in the evaluation or anything, but you have to make a statement related that about thinking of the potential threats or risk that the application of your algorithm can have.
Yes,
and
every conference should do this.
Yeah, but the point is that since it's a requirement, then you can say, well, I think that there might be risk on this, and then that's it. So how professional should we be, and what do you think should be like the, I don't know, let's say that in 2-3 years we should have really committees for this, and so far it's okay if just you require for the exercise of saying, well, this is the potential risk of this algorithm.
Well, I mean, I think this is what faculty can do, when you're mentoring a student, is this is what I do with my students, is I make them think about it, and I make them go into depth. I say that if they write a paragraph on the risks and it's not sufficient, and I feel it's shallow, I tell them, no, you have to think more about this. I want you to take this to other faculty, take this to your classmates, and really discuss it and think about it. We don't have a committee. I mean, if you're going to start you might choose to start a committee in computer science faculty that reviews papers, but speaking as an overburdened faculty member, it's like, oh, that seems really tough.
Yeah, we already
have too much to do.
Big overhead, but we think we know, as you say, that it's super necessary, because if you don't do the exercise, then you have all these unintended consequences, and knowing that there are all the cases that you were describing already in your presentation. Right.
I mean, yes, exactly. So I think we need to think about it more. We need to teach our students to do it more. And then in peer review, when we review someone else's paper, we should really, dig in. If you read I do that too now. If I review a paper and I feel that they haven't really thought about the consequences, I will point them out. And I may even recommend that either they don't accept the paper, or I recommend that they modify the paper to include potential risks. And I think that's a start. I mean, it's not an answer to everything, but I think everybody in computer science needs to start thinking about this. And you can't abdicate it. You can't say ethics is beyond me, I'm not an expert. You have to say, what am I doing with my code and my algorithms to make the world better rather than worse? And you really have to think about what could go wrong. I mean, that is so very important. So yeah, and I don't think committees necessarily are the answer. I think we have to do that that's our duty as faculty members when we teach our students.
Thank you, Cecilia. Yeah, great presentation.
Thanks for that great question, Dennis.
Yeah.
And who else wants to ask questions before somebody else makes another question? I have another opinion or question. The example of the database of the 70s is a great example because it's obvious the bias there. But how can you really discover data bias? If you really try to be as unbiased as possible and you get a huge database, how can you know what bias can be inside that database?
Well, so first of all, that's another great question. First of all, there are a lot of people working in this area and pointing out the biases and the privacy violations that so much of our software is based on. And I really think this is going to be a policy issue. We need more funding. We need to show that doing the work of exploring existing data sets for bias, that's important. And we need to accept papers on it. We need to hire faculty members whose work is based on this. And we need to have funding to create new data sets. Because how can the best data set in this natural language processing world be from the 1970s? That's crazy, And I think actually this is very relevant to people in Chile because so many of the data sets are in English. I think the Chilean government should be funding the creation of a large data set in Spanish, and that this data set should be vetted by people who look at the ethics and the biases of this data set as well. So this again is maybe grants need to be written to say we're going to create a new data set in Spanish, and or a new data set that removes some of the biases. You're not going to have a completely unbiased data set. That's not really possible, but you can acknowledge where the biases are. So you can say, for example, in this 1970s data set, you can say, well, we know there's confounding variables with gender, so we're not going to make any conclusions based on gender. Or if you have a data set of human faces and you're trying to do facial recognition, which in my opinion is a mistake. I think it's not really a good idea to do facial recognition at all. But you can say, well, there are known biases in this algorithm, and maybe we should remove a certain maybe we should only look at people with a certain skin tone, and and only use it for that. We should acknowledge this data set is biased. So those are the 2 points that I would make that I think are very important.
You mentioned the gender bias. Considering that computer scientists are well over 50%, I don't know exactly how it is worldwide, but I would say well over 50%. And there's definitely a different view of the word from male than from female. How do you see the gender bias development? Do you think it's really improving that problem?
Well, I think we need to bring more women into computer science. I mean, that's something I feel very passionately about, that there's sort of an assumption sometimes that, well, women just don't like computer science, or women go into computer science but then leave. And there have been a lot of studies that show that women really do like computer science. As a matter of fact, the first programmers were women. But what anybody, male or female, doesn't like is being in a hostile environment. And I can tell you so many examples from my own life. I'm kind of, I'm sort of a fighter. All right. So if I get into a hostile environment, I'm going to push back and say, I'm going to keep doing it. I'm really kind of stubborn. Yeah. Yeah. Like the Los Aragones, as my father used to tell me, very stubborn. But I think it should be recognized that there are women that maybe aren't as stubborn, and that, you know, they might love the math and the science, but if they're in a room where people are making, you know, hostile jokes or, you know, sexist comments, they're not going to feel comfortable, and that might make them leave. So it's really important to create a welcoming environment for people of diverse backgrounds. And I think when we do that, we're going to grow computer science and other fields to 50%. Certainly, there are examples of how this was done in the United States. There's, what is it, Maria Clave, who, I forget, she was the president of, I'm forgetting the name of her university, but she implemented a specific way to recruit and retain more women in the field of computer science, and she raised it to almost 50%. So it can be done. It just takes very, very strong efforts to remove bias. And it's really hard for us to admit that we're biased. I mean, I'm biased against women. How can that be? I mean, that's crazy, right? But I have to recognize that when I, you know, my unconscious biases will say, when I see an older woman, you know, like myself, I might say, oh no, is she really sharp and intelligent and technical? And I have to say, no, you know, that's my bias speaking. And I have to say, you know, when I speak with somebody, am I making them uncomfortable? And so what can I do to welcome, especially people who are from minority groups or underrepresented groups? If there's, you know, like, it's true, when I'm in a room with 8 women and 2 men, you know, generally the women will try to make the men feel included, you know, so it should be the other way around too. So we should all acknowledge that we are human, we have biases, and we want to make people who are different from us feel welcome in our field. And you know what? That's going to make our field better for all of us.
Thanks a lot. Una pregunta, todavía nos queda un poco de tiempo. Hoy día han participado muy poquito. No sé si hay alguien que quiera hacer alguna pregunta antes de terminar. Nadie levanta el brazo. Nadie quiere hacer una pregunta. Bueno, I will make the last question. Ahí llegó, Dennis, de nuevo, please.
Yes, I have another question. I don't know if there have been progresses on this, because one big issue related with the notion of fairness and preventing bias, considering protected groups, is that we don't know in advance which should be the protected groups. We know now, for instance, that we want to be gender neutral, or we want to prevent a bias against, for instance, in Chile, some native groups or some social groups. But then when we, let's say, apply certain policy, then we realize, we were missing this other group. And maybe some solutions in data science are a bit fixed. And then, now we need to make sure that the distribution of, let's say, a performance of certain classifier is good also on this small group, and we have small data. Have you faced any of these situations, Cecilia? And what do you do about it?
All the time. And my answer to this is, just because the problem is difficult doesn't mean we should give up on it and ignore it. I mean, I've made my career by working on difficult problems in computer science. And I think that's really whatever, you know, you take on the most difficult problem you can think of and you work to solve it. You may not solve it completely. I think it's going to be a work in progress. So yeah, you know, but just because it's difficult doesn't mean that we shouldn't do it, because it's necessary. You know, we can't leave any of these groups behind. And I think, you know, like what I said, sometimes justice requires the ability to bend the rules. So when you build your system, maybe it's not perfect for every group, but then allow flexibility, allow that, you know, maybe something will be discovered later on and your system will need to be changed, or a human will need to override it. Don't build it so that it can't be overridden by a human.
And my last question is related to this. There is some kind of race between regulation and technology. I was involved the last year in a commission within the Senate in Chile, and they were asking me, so what is the state of usage of algorithmic decision making in public in public offices in Chile, in the ministers, in the subsecretaries, and there was a researcher here in Chile from another university who was collecting that data, and she had already an idea. They published a report, and then the team with the senator and other lawyers, they were asking me, so do you think we should have a an institution that imposes certain rules on this? And I was thinking, well, maybe, but the problem is that we don't know exactly of this because the problem is not solved. Regarding the same issue of protected groups, there are certain methods that try to deal with the fact that maybe you might have infinite number of protected groups, but they are all at the theoretical level, as far as I'm concerned, yes, or I understand. And there are other related to fixed groups. So I understand that from the academic point of view, we can address very difficult problems, maybe solve them partially or make a progress. But then when we have to suggest policy laws, yes, I feel completely like, wow, which should be the right way? Like, well, we know the risk of not doing anything, so let's try to put on a rule. But then we might maybe like coerce, fix too much the area and prevent innovation. So I don't know. Right now there is this proposal of the European Union, but it's just a proposal about regulating based on risk. So if you have very little risk, you can just use your AI. If there is middle risk, you need to go through a board, an institution that tells you what to do, how to check your algorithm, your output. And there are certain uses that are prohibited. Among them is the one that you suggested, you mentioned the face recognition.
Yeah.
Only in very particular cases like terrorisms, or if children are lost in an airport, something like this. But what do you think should be the best way to address this? Like, should we be proposing rules or laws, or should not, like we should do this academic, and then when something is already well solidified, there is theory, there is practice, then we can go and propose things in terms of law?
This is a really great question, a really excellent question. So I believe very strongly that we do need some laws and some rules, but they can't be too restrictive. And it's a matter of balance. It's a matter of having, people from various sides of the table be involved, so there should be computer scientists at the table making, helping craft these laws, but there should also be ethicists, there should also be sociologists and policymakers in general, and it should be, a wide group of people that addresses this. And the idea of regulating based on risk is not a bad one. But yeah, there could be, how do you determine risk? There could be some unintended consequences there too. But I think it's important. So I think some regulation is really necessary for true freedom. I mean, this is something that I've seen over. I'll give an example that's sort of outside this. So in a social media system, sometimes people will say, well, we should have complete free speech, no regulation at all. And yet we have found that when that happens, it tends to devolve into people with more power, people who are angrier, kind of crowd out people who are trying to, you know, be truthful or you know, improve things. So the social media systems I've seen that really honor free speech actually have rules. They have people monitoring, they do remove hate speech, they do have rules that people have to follow. So some amount of rules is a good idea. It's really, really important not to say we need freedom from all rules, because that will make us less free.
Thank you again. Yeah.
Bueno, Cecilia, te agradezco enormemente realmente esta charla y el tiempo que estuviste con nosotros. Fue sin
Fue mi
duda
placer.
un gran aporte para todos. Para mí también aprendí hartas cosas que no los veía antes de ese punto de vista, y realmente aprecio enormemente el tiempo que estuviste con nosotros. Muchas, muchas gracias. No sé si Valeria está todavía. Valeria, no sé si puedes también darle un pequeño...
Sí, muchas gracias, Cecilia. Lamentablemente estoy manejando, tuve que salir en la segunda mitad, así que thank you so much. I'm driving right now because I have to leave the second half of your talk, but I thought it was very interesting and I thought it was very useful as well for our students who are trying to work in this intersection between data and the human aspects. So thank you very, very much.
Well, thank you, Valeria. It's great to see you. And thank you all. Muchas gracias a todos. I really enjoyed speaking with all of you. And yeah, and you know, I'd love to come visit sometime. I have visited Chile before. I have family in Santiago and throughout Chile. So so it would be great to continue conversations more in the future. Thank you again.
Muchas gracias. Y para la próxima semana vamos a tener a Tom Reeves de la Universidad de Georgia, que va a hacer nuevamente una charla en inglés y él va a hablar de educación y tecnología. Muchas gracias, que tenga un buen fin de semana. Adiós. Chao.
Adiós.
Thanks, Cecilia.
Gracias,
Chao, buen
thank
fin de
you.
semana.
Adiós y gracias.
Thank you.
Chao.